All right, this is it. The grand finale of our series on operating systems. We're putting all the puzzle pieces together. We've looked at all the individual parts, but now we're going to see how it all clicks together to power, well, everything. So how does one simple click on your mouse unleash this incredibly complex symphony of actions? Let's find out. To really get a grip on how all this works, we're going to use one big, powerful metaphor for this whole explainer. The operating system is a bustling city. Seriously, just picture it. A digital metropolis with its own rules, its own infrastructure, its own population, all working in what looks like chaos, but is actually a perfectly coordinated dance. So here's the game plan. First, we're going to take a quick tour of our OS city just to get the lay of the land. Then, we'll do a rapid-fire meet and greet with the key players who run the whole show. After that, we'll follow a single mouse click on its amazing journey through the system. And finally, we'll zoom out and talk about why this invisible world matters so much. Okay, first stop, OS City. As we explore, you're going to see that every single part of your computer has a role to play here. Think of this city as our map for understanding the entire system. So, who's in charge here? Well, that would be the CPU. It's the mayor of our city. It gets the final say on what gets done and when. And where does everybody live and work? That's our memory, the city's housing system. And just like in a real city, space is limited, it's prime real estate, and managing it is absolutely critical. And what about the people, the ones actually doing things? Those are the processes. They're the citizens of our city. Every application you run, from your web browser to your music player, is a citizen going about its day. And where do they keep all their stuff? All the city's records, books, and data? That's all stored in the file system, which is basically the city's massive public library and archives. Now, you can't have a city without some law and order, right? That's where the security system comes in. It's the city's police force. It enforces all the rules and permissions, making sure one citizen can't just barge into another's house. And at the very, very heart of it all, that's City Hall, the kernel. This is where the core, non-negotiable government services are managed. So if you step back and look at the whole picture, you see the OS is really doing two huge jobs at once. First, it's a resource manager. Just like a city government, it decides who gets what and when. But second, it's a master illusionist. It hides all the messy, complicated details of the hardware and gives our programs a clean, simple, and predictable world to operate in. Okay, so we've got our map of the city. Before we see it spring to life, let's do a super fast roll call of the key players we'll see in action. This is just a quick refresher on the concepts that make this whole thing work. First up, our citizens, the processes. A process is just a program that's actually running. But each citizen isn't just one single entity. They've got threads. Think of threads as the citizen's hands. They can work on multiple small tasks at the same time, all contributing to the same larger goal. With so many threads all wanting to run at once, how does the OS decide who's next in line? That, my friends, is CPU scheduling. Modern operating systems like Linux use what's called a completely fair scheduler to make sure everyone gets a turn. It's like the mayor's chief of staff, carefully managing who gets an audience and for how long. And this is maybe the most brilliant magic trick the OS pulls off: virtual memory. It fools every single process, every citizen, into believing they have the entire city's housing all to themselves. This powerful illusion is created by mapping each process's private, virtual house numbers to real addresses in physical memory. It can even use the disk as overflow housing if things get too crowded. The file system, our city archives, how does it find anything? Well, it uses a nifty data structure you might remember called the inode. Every single file has an inode, which is basically its entry in the library's card catalog. It lists all the file's info and, most importantly, where to find all its pieces on the disk. And finally, synchronization. Imagine two citizens trying to edit the same public document at the exact same time. It would be chaos. To prevent this, the OS uses tools like a mutex, which stands for mutual exclusion. A mutex is like a key to a room. Only the thread holding the key can go inside, preventing a race condition where data gets all messed up. Okay, enough with the theory. Let's see this city come alive. We're going to trace one simple, tiny action that you probably do 100 times a day, double-clicking the icon for your web browser. This one small action is about to set our entire city in motion. This is the incredible journey our click is about to take. It starts as a simple request to City Hall. A new citizen is created. That citizen gets assigned some housing and a time slot to see the mayor. The city archives are opened to give the citizen its instructions, and only then can it finally get to work. Let's break that down step by step.
So your click doesn't actually launch the program directly. Nope. It sends a formal request to the kernel. This is called a system call. It's like filing a petition at City Hall. And what happens next is kind of wild. In many systems, the OS first creates an exact clone of the current process, and then that brand new clone completely transforms itself into the web browser you wanted to launch. So now our new browser process exists, but it's not running yet. The CPU scheduler has to give it a turn. To do that, it performs what's called a context switch. It meticulously saves the exact state of whatever was running before. The mayor basically puts their current meeting on hold. And then it loads up the state of our new browser. This happens hundreds of times a second, creating that seamless multitasking feeling.
Our new browser citizen needs a home. But the OS is smart. It doesn't build the whole mansion at once. Instead, it just promises a huge virtual space. Then, only when the browser actually tries to use a piece of that memory, does the OS find a real physical block of memory for it. And if the city is full, the OS will temporarily move an inactive citizen's belongings to the disk to make room. But wait, where are the browser's instructions, its actual code? It's sitting in a file on your hard drive. So the OS goes to the file system. It looks up the browser's name, which points it to the file's inode. That inode is the treasure map that tells the OS exactly which blocks on the disk to read to bring that program to life in memory. And this whole process perfectly illustrates a really key distinction. If you have a computer with a single core CPU, the OS gives you concurrency. It switches between tasks so incredibly fast that it feels like they're running at the same time, but they're really just taking turns. Now, if you have a multi-core CPU, you can get true parallelism, where multiple threads are literally executing at the exact same moment. So we've seen this entire complex city spring into action from just one little click. It's a beautiful, intricate system. But so what? Why does understanding all this behind-the-scenes magic actually matter in the real world? Because this city isn't just humming away inside your laptop. It is everywhere. It's running your smartphone right this second. It's powering the giant cloud servers that run every app you use. It's in your car, your TV, maybe even your smart thermostat. These core ideas are the bedrock of modern technology.
And here's the bottom line. Understanding this stuff, it's like a superpower. It lets you figure out why your computer is slow by spotting bottlenecks. It's the key to understanding digital security because now you know how the city walls are built between the citizens. This is the invisible, powerful engine driving our entire digital lives.
We rely on this incredibly complex system every single day, most of the time without even thinking about it. It is the foundation for everything we do online. And that leaves us with one last big question. What happens when that invisible but absolutely essential foundation begins to crack?